Okay, so let's start with prayer. Sit in Padmasana. Both the hands in Gyan Mudra. Back straight, neck straight. Gently close your eyes. Long deep breath in. And breathe out. Breathe in. Exhale. Breathe in for Omkar. Om.
Shanti.
Om. 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 Shanti. 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 Join your hands together. Rub them. Put them on your eyes. And slowly come back. So let's see what all discussed. Glasses. Okay. Knee. What are the bones involved in knee joint? Bones in knee joint.
This is what we went over yesterday, right?
Yes, well, like we have 3 days and we have only 2 topics to cover. So I thought let's revise. Yes.
The patella, the femur, and the tibia.
Yes. Together, these two are called the joint of femur and patella is called
Femora patella.
and femur tibia.
Femoral tibial. That's the hinge joint.
Yes.
See, I was paying attention.
Yes, it's a hinge joint. Okay, elbow.
Ulna, radius, and humerus.
What is this joint called?
The humeral ulnar.
Yes. And next, this ulnar radius.
Humeroradial.
And this one is proximal. At elbow, it's called proximal. The radio-ulnar joint.
No, I didn't get that.
And what kind of joint is this? This proximal radio-ulnar joint? It's a, what kind of joint is it?
Humeroradial.
Yeah, but like we studied hinge joint, saddle joint, ball and socket. So
A
this
hinge
proximal,
joint.
no, this is a pivot joint.
Oh,
This
sorry.
is hinge. Yes. Okay. And humerus and radius, these together, they are called
Humeroradial.
Yes. This is also hinge joint. Okay, wrist and ankle. Bones of wrist.
Ulna, radius, and carpal.
Which carpals?
Scaphoid,
Hmm.
lunate, and triquetral. Triquetral.
Yes. Yes. Okay, so we have radius. See, in wrist, the ulna is not joining. Okay, there is a disc in between. There is a disc in between, so it's not connecting with the carpal. So in wrist, we only studied radius and carpals. That's why it's called radiocarpal joint. In carpals, we have scaphoid, lunate, and triquetral. Okay. Then in ankle, what are the bones in ankle?
Tibia,
Hmm.
tarsals, and the fibula.
Yes, tibia, fibula, and tarsal. Which tarsal?
Talus,
Yes, talus. Okay. And what is the name of the bone of your heel?
of your what?
Heel, heel.
Oh, the 𝐘𝐞𝐞𝐫. Calcaneus.
Yes. Okay, so in wrist, we have flexion, extension, radial deviation, ulnar deviation, or this is also called as abduction, adduction. So we have flexion, extension, we have radial deviation, and ulnar deviation, also called as abduction or adduction. Okay. Abduction. This is abduction and this is adduction. And what else we have?
Circumduction. Yeah, circumduction.
In this also flexion and extension, it's called dorsiflexion. This movement. Okay. and plant reflection. And also circumflexion. Because we can also rotate our ankles. Okay, this was about wrist and ankle. Now let's go back to cells. Yesterday we were doing cell, human cell. So, what is the smallest cell in human body?
Sperm.
And which is the biggest cell, largest cell of human body?
The ovaries.
The ovum.
The ovum. Ovaries are not cells, they are organ. Okay, it's ovum. The cell is ovum.
Ovum.
Yes. And which is the longest cell in human body? Longest. Something related to your mind?
Neurons.
Yes. So we were studying about the blood groups, RH factor. Did you understand that concept of RH factor? Why O negative is universal receiver and why AB positive is donor? Sorry, I said the opposite. Why O negative is universal donor? Why negative?
Say that one more time.
Why O negative is universal donor?
I forget why.
Because you see, there is RH factor. Okay. If it is present in the body, then it is positive. If it is absent, it's negative. Okay. So suppose I am RH positive. Okay. And I need some blood. Okay. So I can receive RH positive factor. Like my blood group is B positive. Okay. So I can receive blood from B positive. I can receive blood from B negative, O positive, and O negative. Okay, BB you understand because I have B. O is universal donor, but I'm saying, I'm talking about this concept of plus and minus. So I have RH factor, I can receive RH factor. If there is no RH factor in the blood, it's okay. It doesn't matter. But suppose if I was a B negative, okay, I do not have RH factor. Now, if I receive a blood with RH factor, my body will not recognize it. It will be a foreign particle.
Oh, did we lose her?
And it will fight.
Oh, we just lost you for a second. That was all.
Okay. So that's why this O negative is universal donor. It can give to anyone. We know that O can give to anyone. Yes, but if it is negative, then it can give to all negative people also, positive people also. Okay, RH positive and RH negative. Okay, because then this RH factor for negative people, it is a foreign particle. It will not accept. And if suppose I have AB positive, okay, then I can receive from A, B, O. Positive, A negative. Positive, B negative. Positive, negative. And AB and AB. Positive, negative. I can receive from all the blood groups if I'm A positive. Because I have A, I have B, B. O can give to anyone. Then AB, so I'm already AB. Okay. So I am RH factor positive. So I can receive blood groups from all the RH factor positive. But I can also receive from negatives. Okay. Because there is no RH factor. It's okay, but my body has. There will be no reaction. But if in case I'm AB negative, then I cannot receive blood from these people. I can receive only from these ones. Because this RH factor, if it enters my body will fight it, because this RH factor is foreign particle for me. All right. You can take screenshot if you want.
So when you're like donating blood, what is it exactly you're donating? Just the white and red blood cells and some plasma?
When we donate the whole blood. And then these people decide what they want out of it. They'll do some testing, and whatever component they require, they'll take that.
Oh, right. Okay. So they take everything.
Yeah, they just take everything. This is a general representation of a human cell. Here I have a nucleus. There is nucleolus. There is nucleoplasm. Okay, this is cytoplasm. Then we have this is endoplasmic reticulum. You see, inside a cell, there are various components which we'll study. Okay, like our body has like eyes, nose, stomach, intestine, like that. We call them organs. Here in cell, it's called organelles. Okay, so here, first of all, we have this is cell membrane. This cell membrane is semi-permeable. That means it allows some stuff to enter inside and some stuff to go outside. It will not allow everything to come in or everything to go out. It allows only the things which it wants inside and things which it wants outside. It's semi-permeable. Okay, then we have this nucleus. Nucleus is the brain of a cell. It has DNA in it. Like we discussed yesterday, like I look like my mother. Why? Because her DNA has been passed on to me. Yes. So this DNA, even if it is normal cells like of the skin, okay, when this cell, it divides, its DNA will be passed on. That's why my skin always looks the same. Okay, like same color and same texture. Yes, because the DNA is being passed on. When a cell divides, suppose this is a cell, this is nucleus. When it divides into 2 cells or 4 cells. Okay, so then this DNA, it also gets divided half off. Okay, like in ovum, there are 23 chromosomes. In sperm, there are 23 chromosomes. Together, they form 46 chromosomes. And that's why we have these chromosomes, they contain the DNA. Okay, they contain the DNA. That's why we see DNA from the mother, the DNA from the father. And that's why the offsprings look, even if they do not look, they have certain characteristics. Maybe from outer appearance, they do not look like their father or mother, but somewhere some characteristics will be shown. Okay, but there is a cell which does not have nucleus. Okay, it is RBCs. RBCs do not have nucleus. They have no DNA. Okay, they're manufactured from stem cells in the bone marrow. So this nucleus, it controls all the activities of the cell. Okay. Then we have this nucleolus. This nucleolus, what it is doing, it has all the components to manufacture the protein. Okay, then we have here this nucleoplasm. Okay, so you see this endoplasmic reticulum. It is of 2 types, rough and smooth. This smooth is plain. Okay, plain reticulum, but rough. It has ribosomes over it. These are ribosomes. What are these ribosomes doing? They are the protein factory. And you see, this at rough endoplasmic reticulum, the protein is manufactured. Okay, and then this smooth endoplasmic reticulum, it transports. Okay, wherever it is required. Then we have Golgi apparatus. Okay, this Golgi apparatus. What is this Golgi apparatus doing? It receives this protein. Okay, it receives this protein from endoplasmic reticulum. It receives here Golgi bodies. Okay, what it will do? It will do the packaging. Okay, and then it will deliver wherever this protein is required in the cell. Okay, so it is the post office of cell. Nucleoplasm is the liquid in nucleus. Then cytoplasm. Cytoplasm is the liquid between the cell wall, cell membrane, and nucleus. Okay, so this is nucleus. Inside the nucleus, it's called nucleoplasm. And between the cell membrane and the nucleus, it's called cytoplasm. Okay, this liquid is called cytoplasm. Liquid between the cell membrane and the nucleus is called cytoplasm. Okay, so now we know cell membrane. It's giving a protective covering to a cell. Okay, it's binding the cell. Okay, and it is semi-permeable. It allows some stuff to enter and some to go out. It will not allow everything. It is semi-permeable. It can allow certain stuff to come inside and go outside the cell. Then cytoplasm. Cytoplasm is the liquid between the cell membrane and nucleus. Nucleus. This nucleus, it is the brain of the cell. It has a DNA and it controls all the activities of the cell. Okay, this nucleus. Then we have nucleolus. It has all the components to manufacture the protein. Then we have nucleoplasm, liquid in the nucleus. Then there is endoplasmic reticulum. It is of two types, rough and smooth. The rough endoplasmic reticulum has ribosomes over it, which is protein factory. That means it's manufacturing protein. Okay. Then we have smooth endoplasmic reticulum, which is transporting this protein manufactured in rough endoplasmic reticulum. Okay. Then this protein, it goes to Golgi apparatus. This Golgi apparatus, it will do the packaging of that protein and it will transport wherever it is required. So it is also called as the post office of cell. You can take screenshot. Okay. Then we have mitochondria. Powerhouse of cell. It produces energy in form of ATPs. Okay, mitochondria, it will produce the energy that oxidation takes place in the mitochondria, which is producing energy. Okay, that glucose, it gets oxidized here at mitochondria. Okay, and lastly, we have lysosome. Lysosome. What are lysosomes? Lysosomes are suicidal bags. Suicidal bags, it digests everything. Okay, everything that a cell wants to throw away, this lysosome, it will digest it. Okay, and in the end, when the cell dies, okay, this lysosome, it will digest the whole cell. That's why it's also called as suicidal bag. Okay, you can take screenshot. Can one cell can one cell be one complete organism? Can one cell be one complete organism?
Yes.
Yes.
Example?
Sperm.
No. One complete organism.
Oh.
Oh.
Like sperm, when fuses with ovum, it can produce one whole organism. But sperm as in whole is not an organism.
We lost.
Blood, no. These are microorganisms, which we cannot see with our naked eyes.
Well, like stuff that maybe like, what about like bacteria?
Bacteria, yes, bacteria, virus, amoeba, okay,
Yeah.
hydra. All these are unicellular organisms. Okay, so can you tell me which is the
Oh, okay.
largest cell on the earth? Largest cell
on the earth.
on the earth.
Would it be like the ocean?
No. It's of a bird. Okay. You eat chicken eggs?
Yes.
What is it?
Oh, maybe a whale? No, whale doesn't lay eggs. Does it?
Yes,
No.
it does not lay eggs. Okay. So
Well,
this
the largest
huh?
egg in the world is ostrich, yeah?
Yes, it's the ostrich. The
Oh, is that
largest.
the largest cell?
Yes, it's the largest cell.
I was just thinking about the largest egg you can eat.
What do you just think?
The largest bird on the planet, isn't it? I guess.
Largest bird, I guess. Yeah, it is probably.
But
I'm not sure.
but a whale is a mammal, no?
Whale is a mammal. Yes, whale is a mammal.
Surely that has an egg inside it to ovulate.
It has probably, but it's not considered as the largest cell of whale.
Oh.
It is ostrich.
Oh.
Yes. Okay. So properties of a human cell. So all the living organisms are made up of cells. That means it is the basic unit of any living being. If there is a living being, it has cells. Okay. Okay, how new cells are formed? Generally, new cells are formed by the process of mitosis or meiosis. Okay, the cell divides into two, and sometimes the cell divides into four. Okay.
Okay.
Let's talk about the functions of a cell. Function. What are the functions of a cell? Can you tell some?
To reproduce. To reproduce.
To reproduce. Okay, yes, reproduction.
To transport.
Yes. Transport what?
What? White blood cells, red blood cells.
What?
Transport oxygen. Transport,
yes, transport
vitamins.
everything.
All these
The
things.
function we studied in red blood cells, white blood cells, all that. Okay, cells
Yeah.
are only. Yes, transport. Okay, like blood.
What about to? Sorry. Maybe the function is to fight things.
Yes.
Destroy. I don't know what to say.
Nutrients, oxygen, carbon dioxide, water, everything. Then, something with your brain, something related to your brain. Function of a cell.
To send messages.
Yes.
Through the nose.
Okay. What else?
What about to like? You hear about like when cells attach themselves to bad things in your body, and I don't know what they do. Consume them, eat them, destroy them. I don't know what.
Yes, fight.
Fight.
Different.
Fight.
Unwanted.
Unwanted. I'm sorry, I can't see what that last word is. What's that? Unwanted.
Unwanted
Substances.
Substances. Yes.
Substances.
Particles,
What about to rip?
virus,
What about to
bacteria.
repair?
Huh?
To repair.
To repair. Okay. Yes.
Maybe. I don't know.
Yes, of course. And to produce energy.
Produce energy.
Yes, from the carbs that we take. It's
Oh,
happening in the cell. That we studied mitochondria, powerhouse of the cell.
Oh yeah, cool.
Yes. Anything else?
Not bad.
Okay. Facilitate growth. Facilitate. Okay. You see, when a child is, when I was a child, okay, I was this small. Now I'm like this tall. So the cells were dividing. Okay, that's why I could grow this much. So it also facilitates the growth of an organism, cell division. Okay, from cells only, a cell will divide, then those two cells will divide, then they will divide, then. So it also facilitates the growth. You can take screenshot. Do you want to see a diagram of cell? A picture? I'll show you.
Yes, please.
Yes. Okay, this is how a cell in general looks like. Okay, here we have lysosomes. Okay, so we have lysosomes. We have nucleolus, nucleoplasm, nuclear pores, nuclear envelope, that is the membrane of the cell of the nucleus. Then we have smooth endoplasmic reticulum, we have Golgi complex, we have cell membrane, we have cytoplasm, we have rough endoplasmic reticulum. We have ribosomes, we have mitochondria. You can take screenshot of this. This is a general representation. Not all the cells are like this. Like I told you, RBCs do not have nucleus. Okay, they're manufactured in the stem cells, in the bone marrow through stem cells. Okay.
There's been a lot of talk about how stem cell research and what people having stem cell put into them to repair themselves for injuries and such other illnesses seems to be like the big topic at the moment.
Yeah, it is actually. So we'll discuss maybe some other time about, because it's a huge topic, stem cells. They are being used for transplant, for various purposes. So it's a whole topic, we'll discuss it someday. Okay. So, we studied cell. Then, when a group of cells it forms a tissue. All right. Then, two or more type of tissue form organ. Then two or more type of organs. They form organ system. And this organ, all the organ systems, okay, they form a human. So, a cell, okay, it is the structural and functional unit of a human body. So this cell, when group of similar cells performing same function, okay, a group of similar cells, it forms a tissue. Then two or more type of tissues, they form an organ. Two or more type of organs form organ system. Then all the organ systems together, they form the human body. Okay. Tissue, example of tissue, we have studied example of cells. Now tissue is like the epithelial tissues, the connective tissue like blood, okay, and like cartilage, bones. So here, organs. In organs, we have like stomach, okay, like eye, hand, all that. Okay, these are organs. Then organ system is like digestive system. In digestive system, we have oral cavity, then we have esophagus, then we have stomach, intestine, all that. Okay, the organ system is like digestive system. And then together, all the systems together, they form human body. Okay, can you tell me how many systems we have in our body?
No idea.
Huh?
I don't know.
Okay, we'll discuss this tomorrow. All the
Okay.
systems in the body and type of tissues. Tomorrow we'll do
Okay.
that. So let's sit for prayer. Close your eyes. Sit in Padmasana. Both the hands in Gyan Mudra on your knees. Back straight. Neck straight. Gently close your eyes. Normal breathe in. And breathe out. Normal breathe in. And exhale. Breathe in for Omkar. Om. 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 Shanti. 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 Join your hands together. Rub them. Put them on your eyes. And slowly come back. See you all tomorrow. Have a great
Thank
day.
you. See you
Thank
tomorrow.
you so much. See you tomorrow.
Thank
Thank you. See you tomorrow.
Bye.
Bye bye. Bye.
Bye.